Okay, Bismillahirrahmanirrahim. Now we will talk about one of the serial communication features other than UART that we have discussed in the previous videos. We now talk about the I2c or IIC features on PIC16F877 or 877A, and then we can talk about the SPI. But from now, we will talk about the I2c features on the microcontroller, especially for PIC16F877 or 877A. Let's begin our journey. So the first question is, what is the I2c communication protocol? The I2c stands for the IAC, which is stand for the integrated circuits. Okay, it's normally denoted by IIC or I2c, or even as a two-wire interface protocol at some places, but it all means the same. I2c is synchronized communication protocol. That's meaning that both of the devices that are sharing the information must share common clock signals. That is why we have a two-wire interface protocol, because the one is for the SDA and the one is for the SCL, or the clock itself. So it has only two wires to share information, out of which one is used for the clock signal that I mentioned before, and the other is used for sending and receiving data. So this kind is the half duplex, because they can send or they can receive the data not at the same time, because the devices using the I2c is only one wire to send and to receive the data. If they send the data, they cannot receive the data. If they receive the data, they cannot send the data, and so on. So this is the I2c and the integrated circuits protocols. So how I2c communication works? First, I2c communication was first introduced by Philips. As said earlier, that has two wires. These two wires will be connected across two devices. So the minimum is two devices. One is slave and the other is master. So you can make your microcontroller as a master, and the other device, for example, the sensor, the actuator, using I2c communication protocol, as a slave. So these two wires will be connected across two devices. The one is called master and the other device is called slave. Communication should and will always occur between two, a master and a slave. So minimum have two devices. The advantage of I2c communication is that more than one slave can be connected to a master. Okay, using which is known as a multi-drop. So this is the illustration, the multi-drop system of the I2c connection. As you can see, this is the I2c channels, only one channels, but we can connect it to many devices. In this example, we have 5 devices. There are 2 master right here, maybe Arduino or Raspberry Pi, 2 master here, using some of the address here, right here. And we have what we have here, 3 slaves according to the one is the sum of the sensor for the first slave. The second slave is maybe EEPROM or memory storage. And the other, the third slave is some other sensor. And commonly, typically, this kind of the wiring tricks is using the pull-up resistor. Don't forget to place the pull-up resistor here to make it work of the I2c bus. So the complete communication takes place through these two wires, namely SCL and SDA. So this one for the receive and transmit the data, and the other one, the SCL, is to use to synchronize the clock. So the one is to send and receive the data, and the other to synchronize the clock. So serial clock shares the clock signal generated by the master with the slave, and the other is serial data, or SDA, sends the data to and from between the master and slave. At any given time only, the master will be able to initiate the communication. Since there is more than one slave in the bus, just like this, more than one slave and more than one master here connected together, the master must refer to each slave using a different address. So just mentioned in this illustration or this slide that each device has a unique address. So the I2c bus can communicate with one of the devices using their address. When addressed, only the slave with that particular address will reply with the information while the others keep quiet. This way, we can use the same bus to communicate with multiple devices. That's the general of the how I2c communication works according to the wiring diagram, which involves the serial clock and also the serial data. And where to use I2c communication? The next questions. I2c communication is used only for short distance. Just remember, short distance communication. It's certainly reliable to an extent since it has synchronized clock pulse to make it smart, but only short distance communication. Okay? This protocol is mainly used to communicate with sensor or other devices which has to send information to master. It's very handy when a microcontroller has to communicate with many other slave modules using a minimum of only wires. If you're looking for a long-range communication, you can use, or you should try, the RS232 that we have discussed about it in the UART serial communication lecture. And if you want looking the reliable communication, you can try, or you should try, the SPI protocol. That's it. You can now choose where is to use the I2c, SPI, or RS232. So this one is about the advantage and also the disadvantage of I2c. The advantage is, first, it's faster. Okay, it's faster than the asynchronous serial, and also allowing large quantities of data to be transferred quickly, but it's slower than the SPI. Okay. Now, the bus itself can operate at various speeds, which are generally dictated by the slowest device on the bus. Just remember, generally detected by the slowest device on the bus. So, if you want to make it fast, so you have to change your device to the fastest one. Okay, because generally detected by the slowest device on the bus. Common bus speed are 100 kilobits per second, kbps, in standard mode, 400 kilobits per second in fast mode, and 1 megabit per second in high speed mode. But a no revision of the specification allows for a maximum throughput of 3.4 megabit per second in high speed mode. But again, the bus can operate generally detected by the slowest device on the bus. You can use the features of 3.4 megabit per second, but okay, the fastest communication is according to the slowest device on the bus. If you have a 3.4 megabit per second, but your device is only 1 megabit per second, then the maximum communication is only up to 1 megabit per second, not 3.4. Okay, just remember that. Another advantage is the number of pins required. Connecting a single master to a single slave with an SPI bus require 4 lines. That's for SPI. Okay, because in SPI, each additional slave requires 1 additional chip select on the master. We talk about this SPI features in the next video, on the next lecture. This can become very cumbersome in situation where lots of devices must be slave to one master. Okay, just remember, I2c requires only 2 wires, but SPI is 4 wires, like asynchronous serial, but those 2 wires can support up to 112 slave devices. Wow, it's many devices, but in practice, maybe you connected this I2c bus of only maybe 5 up to 10 devices or sensors using this kind of I2c bus. The third advantage is I2c can support a multi-master system, which means allowing more than one master to communicate with all devices on the bus. Okay. Although the master devices cannot talk to each other over the bus and must take turns using the bus lines. Okay, that's the important notes you have to remember. The other advantage is supports multiple slave up to 112 slave devices that I mentioned before. Yeah. Okay. So the other is support slave acknowledgement, which means that you can be absolutely sure that you're communicating with something. With SPI, a master can sending data to nothing at all and have no way to find out. Okay, that's other advantage compared to the SPI. So this is the advantages of the I2c. What about the disadvantage? First, communication via I2c is more complex than with USART or SPI communication. Why? The signaling must adhere to certain protocol for the devices on the bus to recognize it as valid I2c communications. Okay, so the protocol itself is more complex, but we don't want to talk about it right now. I2c draws more power, remember that, than other serial communication bus due to the open dream topology of the communication lines. So you need to place the pull-up resistor to make it work, but it's always draw more power. 3. Since devices can set their communication speed, slower operational devices can delay the operation of faster speed devices. That was I mentioned before, that right here, generally detected by the slowest device on the bus. This is the disadvantage of the I2c. Okay, slower operational devices can delay the operation of faster speed devices. The other disadvantages is the shared nature of I2c bus can result in the entire bus hanging when a single device on the bus stops operating. That's a nightmare, worst nightmare, okay? Because the device is not operating, so all of the I2c communication is failed. Okay, but we have some of solution. You can cycling the power to the bus to restart the bus and restore proper operation. And then I2c is designed to fairly short range. Okay, maybe on the same PCB as the master or via relatively short cable compared to the USART or 485 or CAN bus. Okay, relatively designed for fairly short range. Just remember that. I suggest you that you can connect your microcontroller with your sensor using the same PCB. Okay, that's I can assure you that it works for many cases. Okay, so next we have to know about the I2c bus library function, because we use the Microcontroller Pro compiler. So what we have here, we have 1, 2, 3, 4, 5, 6, 7 functions built in the I2c library routine using the Microcontroller. But as you know that not all PIC microcontrollers have I2c hardware module. For those which don't have an I2c hardware module, so you can use the software I2c module. But I don't suggest this because many cases doesn't work anymore. Okay, so we need to explain one by one of this I2c bus library function. The first one is called I2c1 init, This function is to initialize the I2c with desired clock, and you have to refer the device data sheet for correct values in respect with F oscillator. This routine should always be called before using any other function of I2c library. And the microcontroller must have a hardware integrated I2c module before you can use this function. So you have to start or initialize using this kind of function. This is note. Calculation of the I2c clock value is carried out by the compiler. As it would produce a relatively large code, it performs on the library level. So therefore, compiler needs to know the value of the parameter and the compile time. That is why these parameters need to be constant and not variable. For example, I2c1 init 1 million. This initialize I2 communication using the 1 megahertz frequency. So the second one is the I2c1 start. This function determines if the I2c bus is free and issues start signal. If there is no error, the function returns 0. Okay. So before using this function, the I2c must be or should be configured first using the I2c1 init function. So there's no parameters here, so you can start write I2c1 start and so on. The third one is I2c1 repeated start. This is the function to issue the repeated start signals. The third one is to idle, to check the status as I2c1 is idle or not. If the bus is free, it returns 1, otherwise returns 0. Before using this function, you have to initialize first. So this example is explained for easiest way or simple way. If idle, then some of the tasks should be operate in this microcontroller. So this is for the read. Okay, read the data from the I2c bus, and this is for the write data to the I2c bus. Okay, this is to stop the signal issue. The function is to stop signal. That's the 1, 2, 3, 4, 5, 6, 7 functions in I2c bus library in the micro C. From the I2c init start, repeated start, is idle, RT, WR, and stop. So that's the library according to the micro C Pro compiler. And if you have a question about can you give us an example of the devices? Sure. This one is the temperature sensor using the I2c communication protocol. This for the right side is ADT7410 I2c temperature sensor. Just you can see this SCL SDI connected, and also for the address A0 and A1, and also for the interrupt. In the left side is I2c temperature sensor is called OpenSmart. Just you can see there's SCL SDA. So this is these two temperature sensor using I2c protocols. The other is barometric pressure. The right side is altimeter MPL 3115A2, also have a SCL and SDA. And what is this? BMP 280 is also barometric pressure sensor. Also this barometric pressure sensor using I2c protocols. So this is the example of MPU 9259 MEM sensor modules. This is they have a I2c pull-up resistor, so don't worry, you can connect it directly to the SCL SDNP. And this is the MPU 9215, and this is the decoupling capacitor to secure this circuit from the grounded. And this is the I/O connector. Just as you can see, you can use the SCL SDA and also the address to configure the address. So that's the example. For applications, we have I2c communication with the EEPROM. We use a 60F877A microcontroller as a master slave, and we use a 24C64 EEPROM as a slave device. In example code, we will examine how to write and read data from the I2c device and show the output on some LCDs or LEDs. We need to produce software, so we need to connect I2c debugger. It means that ICL and SDA of I2c debugger should be connected in parallel to SCL SDA of the 24664. So ICL debugger can be found where CR can be found in the Proteus. You can select the I2c debugger in the CRO component. SDA from RCA4 master to 5, SCL from RC3 master to 6. To display the output, LEDs are connected to port B. So that's it. So this is port B to display the memory that has been read by the microcontroller using this I2c debugger. We can monitor, and this is the storage 24C64 using the I2c protocol. Just you can see this I think I have to here right here. You can see that this SCS is connected to the RC3 and the SDA is connected to the RC4. Okay, the address is going low, so the address of the the 24664 is 0. The address itself is 0. You can configure the address of this EEPROM using this pin configurations. Okay. So the I2c code example microchip according to this kind of the 24664 EEPROM is write 1 to the first memory location, 2 the second memory location, 4 to the third, and then until maybe 100000 to the last address of memory. Then it is read sequentially and output through the port B. So we need to make a function to write EEPROM, to read from EEPROM, and the main itself. So in the main itself, as you can see that what we have here, that the 3SP is you have to store the 0 value because the output is for the port B, the CM apparatus, and also the tone of the ADC. And then you can initialize the I2c, the channel 1s to 1 MHz, and then you can write to the EEPROM using this kind of function. Write the EEPROM I, A from position 1 to 8, position 0 to 7, and delay, and we save the value of the variable A itself, because variable A is we want to use as a value written to the EEPROM, and then we can read the EEPROM. So the first one is how to write. I2c start issue, and then write this kind of byte. You can check 24664 datasheet how to initialize written to the EEPROM itself. CMP address saving here order address to temp. We are temp, so we need to these two function we need to write because we want to write at specific address, and then we write the data and then stop and delete. That is so on. What about the read? It's also the start. It's also the have a command of A0. This is A0, but we need to write the address, repeated start, and then we can write A0 to read the value. Okay, read the data, no acknowledge, using this kind of functions. So maybe we can show you the demo itself.
Hi everyone, this is me Bilal here from microcontrollerslab.com.
I think we
In
have
today's tutorial,
to
what we are data sending to this 01, 02, 03, 04, 05, 06, and this data is saving in this I2c device, and now you can see we are reading data from
reading.
I2c
Okay,
device,
reading.
and these LEDs are glowing alternatively, and you can check the code. Here is the code of this project. First of all,
Okay, that's the result of the application. Okay, the next one is how to interface the I2c LCD using the I2c features. You have to know that the LCD is parallel, but right here we can connect this I2c IO expander PCF8574 to interface LCD with microcontrollers. It's much easy to interface with few IOs. So this I2c IO expander module port is made with chips PCF8574 design for LCD interfacing using the 16-pin header. So this is the IO expander, and this is the IO expander and the LCD itself. So the module is very well featured with a jumper to whether turn on and off the LCD backlight. I think is right here to turn on and off the LCD backlight, and also to adjust the LCD screen contrast using this kind of potentiometer. With solder pads A0, A1, A2, which is left as it will be 111, the address of the I2c. And you can solder any bit of them to make it 0 if needed to address more LCD I2c expander port. The port itself has a power indicator as well as voltage regulator, and most importantly, a header to connect your I2c to wires SCL SD. So this is the connector to connect this kind of expander, I2c IO expander to your microcontroller. Oh, this is the backlight jumper, so you can make it off and make it on using you can connect it using this jumper, and you can see the features of PCF 8575. Please read this. I will not read it for you. You can read yourself. You can pause the video and you can read the features of the PCF 8574. So this is the device address. Okay, you can see in this table, but we have to choose using this kind 111. So to write is 4E and to read is 4F to the LCD. So this is the program, the main program. This is the I2c init. Okay, we it's up to the compiler, and then LCD init initialize LCD module with I2c address 4E, set cursor right string, set cursor right string. So this is only for the function. Okay, so in this function you have to open it with the maybe in the xc.i2c.h, yeah, maybe, or config.h. But please to read this kind of the function, you can access on microdigitsoft.com. So this is the result. Okay. Okay. This is for the Proteus simulator. This is the result from here. That's the result as in from the program from the microdigitsoft.com. You can save the source code, or you can I think you can see the source code of the program itself. Okay, that's for the I2c explanation. You can visit the last of the website to download the source, and don't forget to check this function, because this function is very different from the micro C library function, because they compile the program not using micro C, the other compiler. Okay, so you have to sorry. Okay, that's it for the I2c. Uh, and I hope we thank you very much for your attention. If you have any comment and any question, please write it in the comment below. Thank you very much, and see you for the next video about the SPI discussion, SPI communication protocol. Thank you very much.